3, 2, 1. Liftoff. 32 minutes past the hour. Liftoff.
What do you do when you want to observe somewhere so deep in space that you can never reach it? You send a space observation station. NASA has done precisely that by sending the James Webb Space Telescope to deep space so that it can help us see more of our universe.
There are no limits to the human spirit. I thought I would see the end of physics, but now I think the wonder of discovery will continue long after I am gone.
One of the places the Space Telescope will be pointed at is the very edge of the universe. The findings at the edge of the universe promises to be scary. What will the first telescope see at the edge of the universe? How does it affect you personally? Join us as we explore the terrifying discovery by the James Webb Space Telescope at the edge of the universe that changes everything. Humans have long been curious about what lies in our environment. However, as our research equipment gets sophisticated, we have expanded the scope of our curiosity to deep space. The telescope's invention was crucial in advancing our understanding of the cosmos. There is evidence that the principles of telescopes were known in the late 16th century. However, the first telescopes were not created until 1608 in the Netherlands. Spectacle makers Hans Lippershey and Zacharias Janssen and Jacob Metius independently produced their own telescopes. The story of Galileo and his telescopic observations shows just how much effect a tool for seeing and collecting evidence can dramatically change our understanding of the cosmos. Early telescopes were primarily used for making observations on Earth and helping with tasks such as surveying and military tactics. However, Galileo Galilei became part of the small group of astronomers that was part of a small group of astronomers who turned telescopes towards the heavens. After he got to know about the Danish perspective glass in 1609, Galileo built his own telescope. He would showcase the telescope in Venice, and the demonstration of the telescope earned him a lifetime lectureship at a university. After his initial success, Galileo turned to refining the instrument. His first telescope was able to magnify objects 3 diameters, meaning that it made things look 3 times larger than they actually were. However, with further refining the design, Galileo developed an instrument that could magnify 8 times and eventually 30 times. Telescopes and space go hand in hand. This is because space is so vast that humans visiting some places is simply out of the question. For example, the nearest star to us is Proxima Centauri, which is about 4.2 light-years away. 1 light-year is roughly 5.88 trillion miles or 9.6 trillion kilometers. This means a distance of 25 trillion miles lies between Proxima Centauri and us. Even the Mars planet that Elon Musk is trying to colonize is close by when everything is viewed on the massive scale of the universe. Volunteers will have to endure months and months of travel through space before touching down on Mars to continue living their lives. But the distance is so great, we call on the telescopes. Thanks to the immense power of magnification, we've been able to study the celestial bodies in detail. Some of these telescopes are placed in orbit around a body, like the Sun's or Earth's orbit, from where it peeps into space. One such telescope is the Hubble, which has for decades returned stunning images of the universe. However, a better and more powerful eye has been installed in space, and this eye will help us understand what goes on at the edge of the universe. This is the $10 billion James Webb Space Telescope. Galileo would have never guessed a telescope maker would have such a large budget or workforce from many parts of the world, but the supporters claim it is worth it. This telescope was jointly developed by NASA, the European Space Agency, and the Canadian Space Agency, but it will be managed by the Space Telescope Science Institute. The JWST is a large infrared telescope equipped with an approximately 6.5-meter primary mirror. It was launched on an Ariane 5 rocket from French Guiana in late 2021. The JWST will be the premier observatory of the next decade, serving thousands of astronomers worldwide. It will study every phase in the history of our universe, ranging from the first luminous glows after the Big Bang to the formation of solar systems capable of supporting life on planets like Earth, to the evolution of our own solar system. These capabilities are due to the numerous innovative technologies that were mainly developed for the telescope. They include a primary mirror broken into 18 separate segments that unfold and adjust to shape after launch. The mirrors are made of ultra-lightweight beryllium. Webb's biggest feature is a tennis court-sized 5-layer sun shield that attenuates heat from the sun more than 1 million times. The telescope's 4 instruments, cameras and spectrometers, have detectors that are able to record extremely faint signals. One instrument, near spec, has programmable micro-shutters which enable observation of up to 100 objects simultaneously. Webb also has a cryocooler for cooling the mid-infrared detectors of another instrument to a very cold 7 Kelvin so they can work. How do we know what lies out there beyond the observable universe? We can make inferences based on the laws of physics that we know and by using the things we can measure within our observable universe. For instance, we observe that the universe is spatially flat on the largest scales. It's neither positively nor negatively curved to a precision of 0.25%. If our current laws of physics are correct, we can set limits on how large, at least, the universe must be before it curves back on itself. We can get the best data for our extrapolation from observations from the Sloan Digital Sky Survey and the Planck satellite. The two sources suggest that if the universe does curve back in on itself and close, the part we can see is so indistinguishable from uncurved, it must be at least 250 times the radius of the observable part. This leads to the conclusion that the unobservable universe, assuming bearing any topological weirdness, must be at least 23 trillion light-years in diameter. It must contain a volume of space that is over 15 million times as large as the volume we can observe. However, there are compelling arguments that the unobservable universe should be significantly even bigger than that. What is the furthest astronomical object humans can see? One thing is that there are some objects in the universe that we might never see. Why? About 16 billion light-years from Earth, this marks the current cosmic event horizon of the universe. Are we there yet? Nope, not yet. This distance is the upper limit of light ever reaching us if it originated at that distance today. This implies beyond 16 billion light-years, the expansion of space is faster than the speed of light itself. Obviously, the light will never reach us as it will have to travel through a relatively expanding space. This also signifies that any event that may have happened today beyond the cosmic event horizon will not be observable by us no matter what. But we can see even further through telescopes like the JWST. The most distant galaxy ever observed is the GNZ11, located about 32 billion light-years away from Earth. Mind you, we calculate this distance taking into account the expansion of space as well. At about 46 billion light-years away from Earth, we reach what is called the surface of last scattering. This is what you will observe irrespective of the direction you look at. The surface of last scattering is like a uniform sphere of fog from which the first ever photons of cosmic microwave background radiation came after recombination and photon decoupling. Contrary to the name, it's the origin of the very first scattering of light, but the last of what we can observe. Is this finally the edge of the universe? Yes and no. Technically, this is the farthest point in space and the farthest in time that we can observe. That essentially forms the edge of the observable universe. What lies even beyond that is what is known as the opaque universe. This marks the limit of what we can observe, but not what we can imagine. Let us now go even beyond the edge of the observable universe. What can exist there? All this time, we have only explored what existed at a point in space in the distant past. A more unimaginable question would be, what could possibly exist there at present? The edge of the observable universe also marks what is called the particle horizon, the maximum distance one can see into the past. Everything we have seen so far was from the perspective of keeping Earth at the center and scaling time to the past with distance. This brings us to the question, is the universe infinite? Well, from Einstein's theory of relativity, it can be estimated directly that a flat universe must be infinite. Can we then conclude there is no edge or end to the universe? It is not so straightforward. We have not been able to determine categorically if the universe is finite or not. How? It's like this. The hot Big Bang might mark the beginning of the observable universe as we know it, but it doesn't mark the birth of space and time itself. This is because before the Big Bang, the universe underwent a period of cosmic inflation. Rather than being filled with matter and radiation and being hot, the universe was filled with energy inherent to space itself, expanding at a constant exponential rate and creating new space so quickly that the smallest physical length scale, the Planck length, would be stretched to the size of the presently observable universe every 10 raised to the power of -32 seconds. Sure, inflation stopped in our region of the universe. However, three key questions that directly affect how large our universe is remain unanswered. These questions deal with whether the universe is infinite or not. They are: 1. How big was the region of the universe post-inflation that created our hot Big Bang? 2. Is the idea of eternal inflation, where the universe inflates eternally into the future in at least some regions, correct? And 3. How long did inflation go on before its end and the resultant hot Big Bang? It is possible that the universe where inflation occurred barely attained a size larger than what we can observe. Perhaps any year from now, the evidence for an edge to where inflation happened will materialize, and we will have to adjust our perception of the universe again. But it is just possible that there are plenty of universes out there just like ours, following the same laws of physics and having the same types of physical, cosmic structures. This raises the tantalizing possibility of complex life in one of the numerous worlds out there. There should also be a finite size and scale to the bubble in which inflation ended, and an exponentially massive number of such bubbles contained within the larger inflating spacetime. Then, what does the edge of the universe look like? You must have heard of the flat earthers and probably laughed them off. However, if only they could apply their flat surface theory to the universe as a whole instead of the Earth, they might be right. If you're finding it difficult to imagine the universe as flat terrain, the idea of a geometrically flat infinite universe is backed by Einstein's theory of general relativity, which says the speed of light remains constant no matter how warped spacetime becomes due to the gravitational pull of objects like stars or black holes. For this reason, it makes the most sense, since the total quantity of universe in existence is defined by an event horizon, a boundary through which no light can escape, that is constantly expanding in all directions at a speed that is notably faster than the speed of light. The edge of the universe is defined by something called a particle horizon, which is similar to the event horizon of a black hole, albeit inverted. However, one thing it's important you understand is that the edge of the universe doesn't exist in the way that you might think it does. How? Well, you may assume that the edge of the universe is a point at which you could turn around and see a zoomed-out view of everything. That is, every galaxy, every planet, every star, and so forth. But this probably isn't the correct way to approach this concept, at least not according to space, which explains that even if you were to catch up with the edge, there would simply just be more universe. The theory suggests that this is not necessarily a problem that can be solved by imagining the entirety of the universe as some form of object or point of observation. It simply is. Instead, imagine you were able to step outside of the universe and hold the entirety of its contents in your hand. What will you have in your hands? What you'd probably have is a sphere-shaped object that stays the same size in your hands even as the contents inside shift around. But since the universe is self-contained, we could never truly become aware of an outside, at least not without interdimensional travel. Let's hear what you think the edge of the universe looks like in the comment section below.